Rob, I don't think we can hear you.
Hello everyone and welcome. This is the second of our webinars on Design FMEA. As before, it'll be myself, Rob Farndon, and Andrea Neumann that will be taking us through these slides. If you have turned up today and you missed the first day, don't worry at all, because of course both sessions are being recorded. You'll be able to catch up later. And we will in fact be recapping on certain elements of what we went through yesterday. Today is about providing more detail on the method of Design FMEA that we went through in a fairly swift fashion yesterday. So if I could have the next slide, please. So as I mentioned, today's webinar, along with the one yesterday, is being recorded. And that's a video link will be made available of both sessions. That will be free for viewing a little later on. We'll take questions through the webinar using the chat feature, but please keep your microphones muted during the presentation. We will try to manage the questions and the responses from you through the chat function, and I have some willing helpers for that during the course of the afternoon or morning. Now the next slide, please. So as I mentioned yesterday, we went through the main features of Design FMEA and the main requirements of Design FMEA as it's called out in AS13100. And as it's called out in the reference manual 13004. We explored the intent of all of the requirements inside the standard, and we gave an overview of the actual method as it's presented in the reference manual. And then we signposted for you where you can go for further help and guidance following the webinar. Today is about really unpacking the Design FMEA method in more detail, and we want to give you really some key tips and hints, some care points when we're creating and using the Design FMEAs. So we will be sharing with you basically a stepwise view through the whole of the FMEA method, and we will try to be drawing out through examples and illustrations and the odd quiz what the best way to approach all of the different elements inside the FMEA is. Okay, could I have the next slide, please? So I will just take you through who I am again. I'm Rob Farndon. I work for Rolls-Royce and have done for some amount of time. I'm an expert design practitioner, and my day job of Chief of Mechanical Systems Capability means really I'm in charge of, for civil aerospace, and in fact globally, certain aspects of our design capability, including mechanical design, but also some analytical capabilities too. I'm an expert within Rolls-Royce for APQP and PPAP, and particularly the defect prevention tools, including DFMEA. And as part of that, I in fact led the authoring of RM13004 with a group of people from across the AESQ. I'm also the deputy team leader for the subject matter interest group for defect reduction, RM13004. That's me. Andrea, could you introduce yourself on the next slide, please?
Yeah, sure. So welcome everybody also from my side. So I am working for M2 Aero Engines since 2020 now. Before that, I was a type inspector for propulsion systems at the German Military Airworthiness Authority. So I supported industry for safety assessments. And today I am doing also safety assessments, and I'm certification engineer at the Airworthiness department. So I am the focal point at MTU for system safety assessment and especially the subject matter expert for the Design FMEA. And I led the process definition of interfaces between the Design FMEA and our system safety process, and so supported the definition of both of these processes and the interfaces to other preventive processes at the MTU. So next slide.
Thank you, Andrea. As I mentioned, we'll be using the chat function to ask questions. And to assist us with the management of the chat function, we've got two other experts along with us today. So Steve Pynett and Stefan Doe are here to help us manage the questions. And they will also pop up at different times when we have a question and answer session to provide some input from their point of view and experience. Okay, can I have the next slide, please? So as of June 20th, this data is a little old. There were about 180 people registered for this webinar, and they came from a total of 19 countries. And you can see the split of those, some of those stats from where those people are on this slide here. So we've got quite a lot of interest in this webinar. And of course, recordings available should anybody miss any parts of this. Okay, thank you. Can I have the next one? So what are we going to do today? Really, it's a question of stepping through the different parts of completing an FMEA. And obviously, we're going to deal with them in several sections. First section on the items, functions, requirements, and so on. Okay, it reads stepwise through left to right, essentially, on the DFMEA pro forma. So that's what we're about to do in some level of depth. If you could click on for me, please. Just to emphasize that point, I'm going to recap on just a couple of slides that we saw last time in order to show you the direction of travel here. We've broken it up essentially into these 6 sections. Sorry. If you click for me, please. Thank you. So the first section is all about functions, requirements. It's really about the scoping of the DFMEA. What are you focusing on? What items are you focusing on? And what functions does that item have? What are you trying to achieve is the next question. So that builds on the function by asking what the parameters you're looking for around that function. We said there the DFMEA must include all the functions. There are a few riders on that, which we'll possibly come to, but it's around the scoping of the actual analysis that you're doing. Clearly, if you're doing a new design, you need to consider every function and every part or every item inside the definition. If you're changing a part, if you're modifying a part, clearly you can restrict that scope according to the functions or the items, the features that you're changing. Okay, have another click, please. So the next section will consider how you could get the requirement wrong. So that's the failure mode. How does the design potentially fail to meet that particular requirement? What happens if it fails to meet the requirement? What are the effects of that failure? And how bad would it be? And that how bad it would be is signified by the severity score. Okay, that's section 2. Section 3, you can click, thank you. What about the design would need to be wrong? What would need to fail in the design to cause the failure mode? Okay, so this is not about what physical phenomenon give rise to the failure. It's what design feature we would have to get wrong in order to give the failure mode. Okay, and that's really important because the scope of the DFMEA is all around the design. It's the cause column in the DFMEA that corresponds to D, the design. In a PFMEA, the cause column should correspond to the process step. So the next column is about the prevention control. So, sorry, just click that one for me. Okay, thank you. The prevention controls talk about how we could prevent the design from being done wrong. Okay, what are the prevention controls? Those actions I would routinely take to make sure I get that design of that feature right. And the occurrence score corresponds to it. It's really an expression of how likely it is, or how likely I am to get it wrong, given that prevention control. It's a bit of an expression of your confidence in the design based upon the preventions that you've got. That's section 3. Section 4 is about detection. So how will you check if the cause or the failure mode are present? Okay, if I've got the design wrong or if the failure mode occurs. And the detection score that goes alongside that corresponds to how good a detection it is. Not so much from the point of view of how robust the detection is, how likely it is to detect. It's often more related to how early you're likely to detect whether that cause or failure mode is present. In section 5, if you click me, please, thank you, we'll cover the scoring, which we always say is calculation of the risk priority number, but there's much more to it than that, which we'll come to when we explain that section in a little bit more detail. And section 6, finally, is around improvement actions. The actions required to mitigate the key risks that we identify. So DFMEA is all about key risks. It's all about risks that will be to be identified and to be reduced. But importantly, they are risks associated with the design. It is a design risk analysis. And it is about fundamentally identifying where we potentially could get the design wrong and making sure that we improve the design in order to avoid potential problem. Okay, could you click for me, please? Thank you. So this is the information flow, and I stepped through this yesterday, so I won't dwell on it too much. We're about to go through this in some detail. We'll tell the story through, actually, the example we saw in some of the slides last time. But one of the things I wanted to draw out here is, and pay particular attention to as we go through today's webinar, is the way one column follows from the other one. Okay, there is a natural story here from left to right. It tells a story about the failure mode and how we, and the causes, and how we're going to improve the situation for ourselves. And that's the story from left to right. If you click on for me, please, one more. Okay, the description in each column must flow directly from the descriptions in the relevant cell, which is one of the reasons why precision in language in Design FMEA, as in any FMEA approach, is really important. And I think there is another slide to demonstrate this. If you click on for me one more. The important thing is, or one of the important things is actually that the Design FMEA may be in use for 30 years. And in that life cycle, it's unlikely actually that I will be reading the same. I really hope I'm not reading the same DFMEA lines in 30 years' time that I'm writing today. Even if I wasn't, the point is that I need to explain in clear terms, unambiguous terms, what I actually mean by what I write inside each of these cells. If I don't do that, I lose traceability of information. I lose the thread of thought. So it's really important to be specific about what you're concerned about, what conditions you're concerned about, what the failure mode looks like. And it can turn some of these things into wordy cells. And there's a lot of words involved. But that's important in order to be absolutely explicit about the concern that you have. So we've probably not completed each of these cells in absolutely the level of detail that you would expect to see in a real DFMEA. Some DFMEAs might be that brief, but you might expect more words in a typical DFMEA. We tried to keep it brief so that we can explain it to you. But just remember, when you're actually back in the office doing your DFMEA work, precision of language, make sure it's absolutely explicit what you mean. And I think if we click a couple of times, there's a couple of examples inside the box there. Click again. So you see there's a bit of subjectivity in some of the language. And what we want to do is try and get away from that. So what do we actually mean? The whole diameter is defined as too large. What does too large actually mean? Large for what? Is it because it allows an excessive clearance? Is it because, yeah, so, okay. So thank you. If you click on again, please. One more slide, please. Thank you. Okay, I think at this point in time, I'm going to hand over to Andrea. Thank you.
Yeah. So now we are starting to do the first step of the Design FMEA to talk about the items, the function and the requirements. And one of the main starting points, because here everything is starting if you have at the end a comprehensive Design FMEA. Can you click on the next slide? So the first thing is to define what item you are looking at. For sure, when you later need to look again at the DFMEA, you want to know the one who wrote it before, which item the team meant. So there should be something to identify the item. So a name or a part number, also maybe what kind of subsystem is it, where is it placed. So as much information as you can to define the item should be also in the design information how to find this item. Not every item will need to be considered. So the RM13004 just states that you should do the DFMEA for items who has credible failure influence to the system functions. This means some parts, for example, bolts, may not be considered, but it could be also possible in some aggregated level to name also influence of easier items. It always depends on the aggregated level you want to look at. So click, please. So in every step we are doing now, we just go through the example we already see yesterday. Here we have the item of the fuel air bracket. And I think the naming here is okay because everyone knows now what it is meant. And as a second step, you have to define the functions. And a function is always a description of the design intent of the item. And there could be sometimes that there are several functions of these items. So there could be primary and also secondary functions. And so all of these functions should be written down and should be analyzed. Because at the end, when you just miss a function, it could be also that you miss some critical requirement or even the critical behavior of your item. So click, please. Click, please. So as a first start, we just have here a quick poll in the chat. So please write down which of these functions, which of these are not functions in the Design FMEA. Okay, so maybe we go on the next slide because it's interesting. I just scrolled through the chat and saw the answers. And what are not functions are the 3 and the 4. I think mainly many of you just found out that the loading is not really an adequate answer for a function. The one which many of you named could be, it depends also in what precise language in your company it is should be named the function description. But for sure, it can be that an item can carry an aerodynamic load, so it could be a function description. And the third one is requirement and not a function. So next slide, please.
Number 6 is quite interesting, so I'll pop up,
Yeah.
Andrea, if you don't mind.
Yeah.
Withstand environmental conditions. Sure, we expect a part perhaps to withstand many environmental conditions, but it's not a problem in itself. It doesn't. What we need to think about is the functions that are being failed. And really, it's not a primary function of anything to withstand environmental condition. Something else probably happens because it doesn't. And that's probably where the concern lies. Environmental conditions are usually a constraint around the function we have on a part. So I think that's probably the distinction to draw there. But certainly if you ran through a DFMEA with withstand environmental condition, you could probably get some useful value out of doing so. So it's probably not a classic answer, but not a bad one either.
Yeah.
Sorry. Be quiet.
Yeah.
Thank
So
you.
next slide. So so what Rob also described in the previous slides is about the precise language, and here is also important for the function description. So the RM13004 just states that at minimum there should be a verb and a noun to describe a function. For sure, you should include as much information as necessary to describe a function. So at minimum here, you can see carry load could be an adequate function description, but many of the people maybe do not understand what kind of load and what is meant for the part. So when you click again, there should be a further example here, for example, more precisely the definition of the load. And when you click again, there should be a further descriptions. And again, yeah, and many of you maybe work with Excel, so there's no really a limit how much you could write into a cell for a function. You always have to think that you have to distinguish between the function, which should only describe what is the design intent of the item, and the requirement we will do later. So in the function should not be stated the requirement because it is the next step. So I just made here as the two sentences, as much information as necessary in the function description, but as short as possible, because yeah, you will have a lot of information in your DFMEA at the end, and sometimes you want to just find information fastly there. So be aware that you must have a good compromise between those. So next slide. Yeah, here we have the thing with the poll we had just discussed. So mainly when you are discussing the design of FMEA, you will focus on primary functions first, because there you are aware of what should the item do and what is the design intent at first. but there could be also secondary functions which should not be forgotten. So as I said, this withstand environmental conditions could be sometimes a good approach to just define further requirements, which could be maybe define the environmental constraints. And also maybe axial clearance. I said it yesterday, sometimes you have some constraints depending on other parts and interactions between other parts. So here a secondary function could also be to discuss about clearances or also overlaps. I saw the question carry load between two numbers. Yeah, and requirement then. So you can just split it in the function and the requirement. Next slide. So at the end of the first step, after you have defined your item and also the functions, there should be the requirements. There is the question, where do I get the requirements? I think at first you will just think about the certification requirements because they are mainly the main requirements you would have in mind for your part and also for your design. Then there should be the requirements from the customer, and also these are things which come early in the DFMEA, which are mainly easy to find. But there should you also think about other requirements. So what did you learn from other projects or other DFMEAs? So sometimes it could be a good approach also to look at older design FMEAs and look what kind of requirements has been implemented there. And please click. So looking at our example there, we just defined a requirement for our functions in the standard in a quantified measure of the item function, and there could be for sure multiple requirements. So when you do the first step there, where you just look at one item, you will get a lot of possible functions, and then all of these functions can be widened to further requirements, and so you just will get more and more rows in your design FMEA. Can you please go to the next slide? So there are also in the standard some descriptions how a requirement should be defined. And so we made here some examples. For sure, when we have this transfer fuel function and we just roll this requirement, transfer fuel requirement, it's clear that it's not really a good requirement because no one can understand what you have meant with these three words. So when you click again, also next one to say that the fuel should be transferred in adequate time will only generate more question. What is adequate time and what is adequate transfer? And then when you click again, I hope there is a good requirement then. Yeah. So this could be a requirement. So just write there really the requirement, what the item should cope or should do with respect to the function. So the idea is that the requirement should include functional attributes and also non-functional performance attributes. And this could mean that sometimes it's necessary also to include some environmental attributes there, these so-called non-functional performance attributes. And that everyone afterwards can understand and work with these requirements, it is necessary that these requirements are unique, measurable, and unambitious. So click please again. So there's just one question left. How many requirements should I mention in my DFMEA? And this is quite difficult because at the end you should go through all the functions and should mention all relevant requirements. So sometimes it could be that you say that some requirements are not relevant, so then they can be excluded. But in my point of view, it would be better to just state that you have thought about the requirements and then just mentioned that they are not relevant with an explanation why. So, Rob, do you want to add something?
No, just popping up ready for the next slides.
Okay, so then I go to the next slide and hand over.
Thank you. Okay, so we're going on to now the section 2 of the DFMEA, where we're going to think about potential failure modes, effects, and severity ratings. Okay, if you could click, please. Thank you. So, first of all, identifying failure modes. So, failure modes is about the way in which a particular component, subsystem, or system, whatever's in scope for the DFMEA, could potentially fail to deliver the function. Okay. Each function itself could have several failure modes. If you have a large number of different failure modes, that may indicate that the requirement is not well defined. So you have to go back and understand exactly what the requirement set actually is. If the failure modes only occur during certain conditions, you need to highlight that. Again, it's about precision of language. So if you're only worried about exceedance in a particular pressure value or whatever under certain conditions, let's have it stated inside this, inside this box. But remember that failure modes can potentially occur together, but don't treat those really through DFMEAs. Your DFMEA shouldn't have conditional statements in them which say this failure mode occurs while that failure mode also occurs. Yeah. So, for example, can this load path be unsupported while another load path is unsupported? All right. What we're trying to do here is drive goodness in the design of every element, every item inside the design. So really you want to focus on them individually. And by focusing on those failure modes individually, we should design them out. And therefore it's not an issue anymore whether or not they occur together, because they shouldn't occur at all. There are other tools which are better placed to actually examine the scenarios where failure modes can occur together. Don't use DFMEA for that. Can I have the next slide, please? So I suggest to you 5 different categories of potential failure modes. You can either lose your function altogether. Okay, your primary function is together, your secondary function is lost altogether. It could provide too much of the function or provide not enough of the function. Okay. You could have an intermittent function. Sometimes it works, sometimes it doesn't. It starts, stops, due to environmental conditions often. Okay, but it can be due to transient or emergent behavior inside the part you're designing. Degradation, which is loss over time. Okay, so does it degrade? That can often be expressed actually as an underfunction or an overfunction, depending how you want to handle it. There's no wrong way there. An unintended function is something happening at the wrong time, something that you didn't intend to happen, but it does happen. So this is your classic emergent property, a surprise delivered to you by the machine. It does something that you really weren't anticipating. It's kind of difficult to get those in DFMEA. you need some experience to understand where they might come from. You won't guess them out of the blocks. Okay, can I have the next slide, please? So here is an example. I say it builds on the familiar examples that we've seen. And again, excuse us for using brief language because we're trying to communicate the concepts here. So our item is the fuel pipe, the function, verb, noun, pair, transfer fuel. Thank you. The requirement, the good requirement we came up with, puts the measurable boundaries around that, which says I want to transfer 1 litre per second at 50 bar pressure. Okay. And then some suggested potential failure modes. I deliver too much, I deliver too little, or I deliver none at all. Okay, that's all you need. It's purely a functional consideration at this stage, really. And then we build onto that. Okay, next slide, please. So remember I said about the building of this from the column on the left to the column on the right. There should be a natural logical flow between the two. So it naturally follows that you should be able to connect your failure modes to the requirement and to the function which are next to them. So you can see here some examples where that you can actually see that natural flow. A lateral static load of less than X Newton is corresponding to a failure mode of it being greater than X Newton, by too much, and so on. But for instance, look at the one in red, loss of bracket function. What does that mean? It doesn't mean anything. Well, it does mean something, but not in the language of the DFMEA. What we're really concerned with the failure mode, of course, should go back to a function. If it doesn't go back to a function, it doesn't really. So let's try and make sure there's a logical flow from one box to the next. The next slide, please. So when we're thinking about failure modes, you need to ensure that the right failure modes are captured. The requirements description must be precise. Putting a good requirement down will enable us to think about some very sensible failure modes that go alongside the requirement. Okay. If I haven't quantified the measure, quantified it for a particular function, then it's difficult to know if I've done too much of it or too little of it. So it's about building a requirement that makes sense in the context of a functional description for what the part needs to do. You must connect your failure modes to the functions. If you don't do that, you're actually not doing a DFMEA. Do not specify different increments of the failure. You'll get to that through considering effects later on. But really, this should just be about whether or not you fail to achieve the function in various ways determined. Don't add failure modes where there is no requirement or function. Yeah, it goes from the simple left to right description. Failure modes should be finite. Once established, they can be captured in the failure mode library and used. Right. What we're saying here is that the whole business of these first parts of the DFMEA can be captured as a standard set of concerns that we might have for this particular type of component. A particular type of component, piston ring, will always have the same sort of functions, and you'll always be looking for the same sorts of requirements from it. You will always get the same sort of behaviors in terms of potential failure modes from them, so you can reuse them, irrespective of what comes later in the DFMEA. Keep that database updated as new knowledge comes to light, say from service experience or whatever. Okay. So thank you. Could I have the next slide? Which I think talks about, yes, potential effects of the failure. So effects are really the consequences of the results that correspond to each failure mode. They should be listed in the DFMEA for each failure mode in the potential effects column. That makes sense. and it should be considered against the local next highest system level and the final product level. Okay, so that means if my component fails to deliver on a particular function, it fails to transmit a load, that will have a potential concept higher up the system level that might need to be considered in the design of that system level. So the effects propagate upwards. It's important to try and express, if you're doing a component DFMEA, where you think that effect propagation is going to go. And that's one of the reasons why we often suggest that your next highest system level should be represented somehow inside the DFMEA team, so that you can understand the consequences of any failure mode propagation that you have, which, as we were discussing yesterday, implies that you need some information across company boundaries in some cases, where a design make supplier might be doing a DFMEA and needs to understand something about the system architecture and the way it behaves. It's not possible in many cases to do a component DFMEA without that sort of knowledge. So we should state clearly in the effect of the failure where it could impact safety or non-compliance to regulations. Now that's really important, because that indicates we should be scoring higher, and it indicates we should be focusing on it perhaps a little bit more than we would do some of the others. You can have multiple effects in the DFMEA, include all reasonable effect propagations, okay, but you can capture them in a single cell. So if you believe that something is going to lead to customer annoyance as well as a potential safety issue, as well as a loss of some secondary function, let's pop them all in, right? We'll pop them all in as potential effects, albeit we will only use one of those scores later on. Right? And there's a reason for capturing them all, in that if we treat one of the effects and nip it, some of the others might come into play, and we might need then to address those. So it's important to keep that history of what the effects are and how severe they are. Okay, thank you. I will have the next slide, please, which I think just illustrates some of the potential effects that we might be interested in. So in fact, we've got two examples here that correspond to our previous example. Increased loading on the tubes and fittings, early fuel, tube cracking, fuel leaking, fire, explosion, safety hazard. You can see a chain of events there. And it's kind of important. Remember, we talked about being very precise in the language. The way this thing propagates, you can see there, as is indicated inside that effects column, is quite important. It'd be important to other teams who are taking your DFMEA and potentially using it to make allowance for the effects in their design. Some templates in some companies, and I know Rolls-Royce does this one, divide the potential effects column into component, subsystem, and system, just to try and provide an indication where different teams might need to be concerned. There's a question in the chat I see: should effects all go into the same line then rather than one line per effect? Approaches can vary. If you're certainly filling it out in an Excel template, then you can actually put them all into the same box. Some softwares handle multiple lines for different effects. So we're not dictating any particular approach here. We're suggesting they could all go into the same box, but and that's a minimum requirement that we're looking for the organisations to comply. So, as I say, certain softwares will handle more than one effect. For now, make sure we've got them itemised in the cell. They don't have to be separated, not necessarily. Okay, could I have the next slide, please? Right, so am I miserable or am I not? Am I glass half full or glass half empty? So in any particular DFMEA, you'll probably get a pessimist and an optimist. That's this typical human behavior. But we're trying to get to here, the key word is realistic. What do we think is the most realistic effect, the most realistic way that this thing is going to manifest itself? What are we likely to see? And go for that one. Now, if you have a discussion which indicates a range here of potential behaviors, yeah, just take a view on what you think the most credible answer is. Perhaps do some consultation from service engineering or whatever. I might give you an idea of what might happen typically, what the main concern might be, and go with that one. The key thing I think here is probably not to agonize over it too much. If you're ordering about 7 and 8, just score an 8. You know, I think the key thing is to make sure that you capture a reasonable score and use it. Okay, because the numbers just serve a purpose of prioritization, right? They don't get consumed for anything else from a DFMEA. It's all about focusing on the key things that you need to get right inside the design, right? So we don't really need to be that precise about the numbers. We just want the right behaviors to be driven, the right focus. Okay, I hope that's helpful. Now, could I have the next slide, please? And so this is the severity scoring that we provided in the reference manual. Now, it goes across certainly into the Rolls-Royce internal standards that we use for severity. Okay, it's the same kind of description, and it's kind of a standard sort of approach where you get 9s and 10s for safety related stuff and 1 for no really discernible effect at all. Awareness to annoyance, secondary function and primary function. Okay, distinction between a primary and secondary function, I'll give you that, because that sometimes comes up in questions and answers. The primary function is something that we're asking the component to do. The external system requires the component to do this. Secondary functions are usually to do with the specific solution that you've chosen. So we are asking, for example, because we've chosen to make our component out of a conductive material that has a certain conductivity because of lightning strike criteria or something like that. We've made a decision, and on the basis of the decision that we've made, that requires another function that we hadn't previously thought about. Whereas the primary functions are the things that the system itself is looking for the black box of the component to perform. I hope that's helpful. Okay, so we're going to score this in accordance with this ranking criteria, and we're going to score it without looking anywhere on the right-hand side of that column. Okay, we're not going to look at occurrence or detection, and that's really important because we don't want to lead the witness, and we don't want to pretend that we haven't got a problem when we have. So at that point in time, I usually say, cover up whatever you think about what's to come next on the right-hand side. Try not to think about it. Life's complicated enough. Score it on the basis of what you know about the failure mode. Okay. Thank you. Could I have the next slide, please? Okay, so I've already covered this to a certain extent. So safety concerns through loss of functionality, through nobody would really notice. That's the way the severity rankings work. Could I have a click, please? And here we see the severity is added to those particular failure modes. In this case, it's not at all contentious, because I've got the word safety hazard in my potential effect, so it's a 10. Right? They tend to be the easy ones to score in a DFMEA. Okay, but it's a 10. Now the next slide, please. So I'll give you a bit of a summary then before we move into a first time of questions and answers. We'll at that point be around about halfway through the DFMEA, so we're doing fine for time. There could be multiple effects per failure mode. Remember that, and you're going to score them all, but you'll probably only use one of them later in the scoring. They should include the impact on the customer and the end user. Keep the effects description clear and concise, but it needs to be sufficient to communicate what you're worried about. Describe in terms that will help determine the severity score, and inform other teams about what it is that you're concerned about in this failure mode. If the severity score happens to be 1, no discernible effect, then there is no need to do any further analysis. Just don't fill in the rest of it. Honestly, just leave it. Okay. If I have one more click, please. We are into a time of question and answers. So, has there been, Steve and Stefan, any element of the questions from the chat that we haven't dealt with along the way, or we feel we need to pull out just now?
Looks like the major question was the difference between requirements and functions.
Yeah, so it's probably worth just expanding that a little bit. And I think, as I mentioned in the chat, I tend to keep the function as a fairly simple verb-noun pair. And I think that's fairly good discipline for a DFMEA overall. It helps people to understand what it is we're trying to do. The requirement should, of course, be related to that verb-noun pair. So carry load, transfer load. But it should put any necessary criteria and constraints around it. So carry load under which conditions? Carry load of how much? Yeah. Carry load without a deflection or with a deflection less than. These sorts of criteria are quite important because they help communicate what it is you're worried about with that particular function, and they lead on nicely to the potential failure modes which come next. So just think about the requirement as building the criteria around the simple function that you just written down, if that helps. Anybody to add anything? Any other things to pull out?
No, I believe they've been addressed. Oh, here's one. If product effect is leading to engine fire, but we have a good detection system in place to prevent that failure stage, how do we rate that effect, please? Do we have to be pessimistic in rating our severity?
Right, so if you've got a system built into your architecture that detects the fire before it occurs and shuts it down before there's any detectable hazard, you don't score it a 10. So this is one of the reasons why you need to understand the system architecture before you can effectively score the DFMEA. What you know of the system architecture, you might say a particular component failure, our fuel pipe, might lead directly to a fire, and that will be a really hazardous fire because there's nothing to shut the fuel flow down. Right? If I introduce a system to shut the fuel flow down, potentially it doesn't become that serious. Does that necessarily mean that I don't worry about that failure? Not necessarily. So this could work out in a number of ways. If I start without the system being in place and I start with a 10, right, I might be escalating to the higher system level that they need to put some other system in place, which will mean the severity for me is less. Okay, and that will happen later on. We'll perhaps see an example of this later on today. So it kind of, you score it based upon your understanding of the system at the time you're conducting the DFMEA, right? And subsequent design actions to that assessment may modify that score, but you won't record it there. You will record it further over on the right-hand side of the DFMEA. Okay. So if the function is to transmit torque, for example, is a question in the chat, the value of the torque will be determined by design and interface with other components. What would be the requirement? Face with other components, what will be the requirement? It will be the requirement, the duty you're expecting of that component as it sits in the architecture that you know. So these requirements can emerge over time, they can vary over time, depending upon the assumptions that you're packaging around the design. So that's a good question, Tony. And I think it does. Some of these things can't be determined until you're somewhere along with the design, but that's usually about the design of the system necessarily, rather than the component that you've got. Okay, I think I'll move us on given the time constraints, if that's okay. And I think Andrea now is going to take over with the next section. Is that right?
Yes. So I take over for the next section 3 about the causes, prevention, control, and occurrence. So just click for the next slide, please. And we are going back to the example we just saw the whole time, and now talking about possible causes for the failure mode. And you see here several possible examples, how it could look like. And on the next slide, we will define a little bit more in detail how can we define a potential cause. So please go on the next slide. So the first bullet point is really important. So a cause is always an error in the design that leads to the failure mode. This is, in my opinion, the main problem sometimes which happens in generating a DFMEA is that you have to really talk about design errors. So not about how it could be manufactured or how likely is it that this will happen in manufacturing process later on or in service. It's really depending on design. And so it's the question, how can the design be wrong to lead to this failure mode? And when you're doing the method, you just go through, and for every failure mode, you define a potential cause. Sometimes it could be that several causes can lead to one failure mode. So then you just make several rows to define these different potential causes. And here it's the same as for the whole method. These causes should be listed as concisely and completely as possible. So also when you are later later go on in the design process and you get more information about the design and further main failure mechanisms, you can just add further causes in your Design FMEA. So there's a question, what would you do when you do a DFMEA for a system? It depends. It depends how you define the level of how deep you want to go at the beginning of DFMEA. So when I do the method for a system, I just go down to the component and just talk about the function and requirements for the component itself and define how they can fail. But later on, I just go further down with the components and the items and just define there how the item could fail and how features could be wrongly designed. So that you at the end have at the beginning maybe a higher level because you have not enough information, but further in the process you go further down until you have the lower level systems and the courses there. So next slide, please. We have again a quick poll about potential courses. And here we have also the question now, which are not potential causes aligned to the reference manual. So please just write in the chat what you think is not a potential cause. Rob, do you want to add something?
I was just going to help. There's an awful lot of responses, which is good, isn't it? And there's quite a lot of variation, which is also interesting. I think, as before, shall we show the answers and then just provide a little bit of a description?
Yeah, we just go on the next slide.
Yeah.
And click again, maybe. Okay.
So the thing I would say about this one is there's an awful lot of confusion usually around causes and mechanisms. Yeah, which is why we separated the answer out in this sort of way. The mechanisms are, let's say, physical phenomena we need to design for or allow for in the design. Whereas the potential causes are all elements of the design that we could get wrong. So you can see the delineation there of the potential causes. They're all things in the design that we could do some maths on or whatever and get wrong. Right? I would say the mechanisms over on the right-hand side are things we need to be careful of, the physical phenomena we need to watch out for when we actually create the definition of our diameter, of our tolerance, or of our radii. Okay. Think about it in that way. So that is probably the most common error when it comes to populating the cause column, is confusing cause with mechanism. Cause in the design FMEA is the design.
So then click just again. So I think there's just a short description what you just said, that we have to be aware about what is an effect or a consequence and the result. So the mechanisms could be for sure described in the effect, what happens if the design is wrong, but the causes are only the error in the design. Okay, so next slide. So maybe we just answer first the question about the functional causes for failure.
Well, for certain, you've got the point is, and the way to read a DFMEA is that the cause or an error in the definition, which is the cause, gives rise to the potential for the function to be failed. Yeah, that's always the way you should go about thinking about this. So are there functional causes for failure? Not in the context of a DFMEA. That's not the mindset. The causes of failure in the DFMEA are the way the design could fail, not the way the component could fail. So a failure mode in the context of the DFMEA is the way I fail to achieve a requirement, right? You know, it's quite important to get that mindset right. So I don't think functional causes are really something that you should have a conversation around in the DFMEA. That's really not the way to think about them. For sure, there are mechanisms, and including a mechanism against your cause is sometimes quite helpful, right?
So thanks. So then we
and quite often, you know, we'll have that column inside the DFMEA too in certain templates. Okay, sorry, carry on.
No, thank you. So then we just go on with prevention controls. Yeah, so we made just a short examples in our big example, what could be possible prevention controls. In the reference manual are some things named which could be included in the prevention controls. So you could think about if there are some standard guidelines and norms for your design so that you are sure that when you just use them, that this cause maybe will not happen. Also, lessons learned and best practice could be a good approach for prevention controls. And for sure, if you do some analysis or design studies just to understand your design and to prevent this cause, or if you just did some testing before design freeze to get these design, could be part of the prevention controls. So everything what you do before design freeze to get a solution which should prevent these cause at the end, so that you just focus on this design change and think about what will be done in the design process to prevent the cause, could be added in the prevention controls. And when you click then next, okay. Yeah, also one mistake which is sometimes made is that the prevention controls should not rely on manufacturing and build controls. I think when you just think about the slides we just discussed before, it's clear that when you just talk about design failures and causes which can be produced in the design, you cannot find this failure in manufacturing or build controls because the failure is already in the design. And so you cannot find it then with the typical quality measures of in the manufacturing process. So next, please. Okay. So with these prevention controls, we go into the occurrence scoring. So for every cause, we define the prevention methods for this special cause, and also then the ranking number depending on these prevention methods. It represents the likelihood of a cause, but it is not like for FMEA, for example, that you just define there a probability or something. So it's more that you just define how sure you are that the cause is not in the design, depending on the prevention controls you just listed there. So when you're sure that when you can be sure that with these prevention controls, the causes is prevented, as the word says, the occurrence scoring will be low. This means not that you define something that the failure will not happen in service, because it's always the rating to define that you are sure that the cause is not happening in the design, so that you did not implement the failure in the design. And on the next slide, we just now have the occurrence ranking copied from the reference manual. So this is the proposed scoring you should use with the wording to number your prevention controls, and also get then the rating for the cause. And when we go now on the next slide, we will see it on the example. And you can also see there that it's always the lowest occurrence you just got from the prevention controls. I think we mentioned it yesterday at some times. So at the end, the lowest numbering tells you the confidence of the prevention controls to prevent these cause of failure mode. And so also this occurrence numbering should then be used for the later risk calculation. So then you can go on the next slide and I can hand over to Rob again.
Thank you. Okay, so we can click again, please. We're talking now about detection controls. So this is how a design cause or the failure mode is detected. You can use analytical or physical methods. It can be it needs to be before the item is released to production. We're not talking about an in-service detection. That will be treated quite differently within the DFMEA. So this is all about protecting the customer from an escape, a bad design. How do I detect that the failure mode or the cause are present inside the design? We should include all activities planned and committed to be performed such that they detect the design error prior to production release, so before the customer has the potential to get their hands on it. And again, it shall not rely on manufacturing or build controls as detection controls, right? The design to be inherently good. So we need to keep that lens on the entire thing. Could I have the next slide, please? So with the design controls for detection, we've got some examples here. In each of these lines, actually, we're suggesting that there's a durability test in the first two cases that could be performed. And that is part of the standard approach for this type of component. Got at the bottom there that the build process will detect. That is not operational. What we're talking about, XYZ build process there is actually the build of a development vehicle. But that's probably something we should have written in that box. Okay, so this is all about the ways we're going to detect this problem inside phase 2, typically, of APQP, the product design and development environment. Okay. Click on one more, we will get the scores associated with them. Not yet. I'm coming on to scoring now. So the rank is associated with the best design control from the list of detection type design controls. Again, you cover up the rest of the sheet when you're scoring it. Okay, so it should be an ignorance of the severity or the occurrence number. Detection versus service detection. As I mentioned, the goals of the DFMEA is to increase the ability to verify and validate a design prior to start production, prior to going into the operating environment. So in service detection, would not find the design failure before then. Okay. Talking about in-service detections or detection systems in service being in operation, they are part of the architecture, they're part of the design. And so you should be scoring your design in full knowledge that those in-service detections are present. So we should usually change the severity, not the detection. Okay. Could I have the next slide, please? Here we see the detection rankings inside the DFMEA. Again, this is a fairly standard sort of list of the detection rankings. You see within within two of the main blocks there, we've got our distinction between pass-fail testing and testing to fail, failure testing and degradation testing. And that's just a way really of delineating what is considered to be a better testing method. Predominantly the score that you get for a detection control is related to exactly when inside phase 2 of APQP, inside the development program, you will discover that failure mode or cause is present in the design. Could I have the next slide, please? Which I think just illustrates that even more clearly. So blocks 3 to 3 to 5 there. Detection in the early project phase, click. Then you've got detection not required. So I've designed it out. I'm not going to see this. Okay. Next click, please. So there in between those two, I've got reduced robust early detection. I've got a really good analytical method that will nip it in the bud, and I won't need to worry about testing. That's what that one means, number 2. You get detection late in the project phase, which is 6 to 8, and then 9 and 10 are really about poor detections, with 10 being there's no detection method at all. If that failure mode or pause is present in the design, there's no way you're going to detect it. So you need a low occurrence from occurrence. You need to be confident in your design. Okay, can I have the next slide? Thank you. Okay, so using your chat function, audience participation time again. Could you try and score for us, please? What's the score for these particular detection controls? Just use your chat function and the sheet available to you there. I think people are thinking really hard about that. Getting some responses now. Okay, I'm going to cut that one short and show you the answers if you click on for me, please. Thank you. So there you have it. We've got 2 8s and a 6. I think some of you got some of that right. And it's fine at this point in time. This is a training exercise after all, to get this slightly wrong. But you clearly, most of you have got it pitched in the right group at least, between 6 and 8. It is about, it's going to be discovered fairly late on because you've gone and built a vehicle and potentially you've gone and tested it before you actually discover this. So it's actually quite a long time after the design potentially has been frozen. So that's what gives those scores there. Okay, thank you. Could I have the next slide? Andrea, could you carry on, please? I'm conscious of time. We have about 40 minutes left.
Okay. So then we just go on with the risk priority number just in a short step. So the risk priority number is the severity multiplied with occurrence and detection. And the ECC in the example is quite easy. But when we go on the next slide, when you just have several rows with different occurrences, it's always the question, which number should you take? So we have each course gets a separate line we just discussed before. And we also named several effects. And as we discussed before in the severity step, when you click again, you will see that we always take the highest severity score because this is the failure which could happen on the worst case. In the next click, we will see the occurrence should be the lowest one, but not the lowest for the overall failure mode. So every course has its own occurrence, and so we have to take the lowest one for every course separately. And then we go to the detection with the next click. And there we just see also the detection always is in connection with the course. So we can just take the lowest detection score corresponding to the best detection for this course. So when we now click again, we will see the multiplied risk priority number. which is always the highest severity score and the lowest occurrence and detection scores for each cause. And there you see the different scoring. And I think this is all which is in my part to show you. When you click on the next slide, yeah, there should be the improvement actions which Rob is explaining in more detail.
Okay, thank you. I was just in the business of typing an answer to an earlier question in the chat, so I think I'll mop that one up before I carry on. It was a question about whether or not something could occur, a single prevention control could occur in both, single control could occur in both the prevention and detection columns. I personally, I think it could. The same thing that leads you to design out or identify an issue before design freeze could actually detect it. Yeah. And that's particularly true of early analyses. So if I perform an early analysis, it could actually inform the final design as well as detecting that the error is present. All right. So there's an overlap. There's an overlap. And particularly that's true for early analysis and early test, because quite often they come in time to inform the final design before design freeze, which is where you get the occurrence score. Okay, so they can be prevention. I hope that clarifies that. So we're going to move on now to improvement actions. If I just click on one more, please. Thank you. Oh, so I love this slide. It communicates so much. So how you're going to prioritize your lines in your FMEA for action. We call this the RPM Pareto, this chart, which is basically how many of each RPM you get. Okay, drops down, of course. The key message here is if you've been operating in an environment where you tend to use a threshold below which you take no action, please don't. Okay. The way to approach this is, first of all, to look for those failure modes, those causes that give you high severity, design those out. And then you look at the combination of severity times occurrence score, and you design out those failure modes, right? That's the way to look at this thing. And the reason you do that is that you want to prioritize the things that stop an error from occurring. And the earlier you stop an error from occurring, the better. So if you can nip it in the bud before you've frozen the design, that's much better. Yeah. So look for the high severity times of occurrence score before you even think about RPMs. A question in the chat is designed out. What I'm looking for, really, we are looking for a principle of as low as reasonably practicable. So certainly where I have a safety-based failure mode and either a 10 in severity, or even for some of the functional failures, primary and secondary function, I always ask myself what I can reasonably do to improve that score. And if it's a fairly easy activity to do, I will go do it. Yeah. So by that, you nibble away at the scores. They come down and down and down. Is there a point at which I stop? That is subjective. There is a point where I become satisfied, and it's up to the design team to identify where that is, but I wouldn't use a threshold. Okay. It's always whether I can do any more, whether it's viable to do any more. Okay. So thank you. Could I have the next slide, please? Okay, so how we reduce those scores then that we've identified. If you've got a high severity, I think I've already alluded to this today, and I did so yesterday. A high severity can only be reduced through product redesign. And by that, I mean probably not the component you're working on. It's probably something higher in the system level that needs to be considered. An extra system, a fail-safe system, or redundancy somewhere in the system that needs to be built in order to reduce the consequence of your component failure, your failure to achieve that requirement. Okay, it effectively reduces the requirement. So occurrence scores. If you've got a higher occurrence score, that can be addressed by generating more knowledge, effectively improving your confidence in the design. It might be through extra analysis, might be through extra testing, looking at experience on other engine types, other vehicles. So think about how you could improve your confidence that the specification you're about to put on there is a good one in light of the requirement. And those actions could be considered to improve occurrence. Detection scores, again, if you think about what we just said about detection and where it is, more robust or enhanced testing and earlier testing are the things that are going to improve your detection. Okay. But the order, the Pareto here is definitely to think about severities first and occurrences next. Okay. You see what I mean? It's about designing out those high consequence failures before they get to the point at which you have to worry about detection. Detection is the last refuge of the scandal. Okay. You need to be able to demonstrate, really done as much as possible to design out the error before you put a test in. Although some testing is a good thing to do, clearly. It's good value. Okay, could I have the next slide, please? So a couple of examples then. So here we have our potential cause of the tube locating hole allowable diameter is defined as too large. What additional controls or additional actions could I do? And we fill those in the recommended actions section, the improvement action section of the DFMEA. So if you click for me first, the first example, thank you, Becky. Here I have improved my detection score from 8 to 6. It's actually 8 till 4. Yeah, I just noticed. Yeah, that's an error. By changing the verification schedule, I've pulled forward a testing. Okay. Accelerated testing. In the next example, if you click for me again, thank you. Here I've improved my occurrence score from 6 to 2 by gaining more experience within design. And I've done that by doing some tube wear analysis, high cycle fatigue analysis to make sure that everything's good. Okay, so clearly two different things I've addressed there. I've addressed one with a detection action, I've addressed one with the occurrence action. The best one, in my view, is the occurrence one. Okay, it's further upstream. It will nip the problem in the bud, and it won't go to the extent of having the expense of having a test. Okay, so those sorts of factors come into the selection of your particular measure. But notice in both cases, I have not modified the scores over on the left-hand side. They remain. Okay, they are based upon the standard, the set of controls that we put into the plan at the start. Okay, the improvement actions are just that. They are ones that are resulted from the DFMEA activity. We are actually building more value into the design process. They're improving our situation, reducing our risks. Okay, thank you. And the next slide. Okay, it's question time again. Steve and Stefan and Andrea, I was busy presenting, so I didn't really watch the chat too much during that lot. Would you like to summarize any questions that came up that weren't addressed?
There's a question on the detection with the cause or with the failure mode. I know Andrea answered that it could be both. I know from the previous slide we said the detection is typically linked to the failure mode. I don't know if we want to clarify.
Yeah, it's linked to both. So you are doing for one failure mode the causes, and then you just write down for these causes also the detection. So it could be that several causes will be detected, or the failure mode will be detected with the same detection method, but it always depends on the detection you just write down for your course. So you have it to do it for every course again. Sometimes it could be the same.
And then there was a question, why do we always take the lowest detection score? Wouldn't this provide an artificially lower RPN score resulting in actions potentially not being taken? This could result in a defective product reaching the customer. We potentially could have prevented this by acting on the higher RPN value if you'd use this and taken actions to improve the detection.
I think this comes down to whether or not you believe in the detection controls you built in there. So if you've put a good early detection in and one that you have high confidence in, you should be able to stick to your guns and say, well, that was a 4. I could go and do a later test, but I don't really think I need it. Okay. So it comes down to a few things, really. I think if you got a good validated test or a good validated analysis that you have a high level of confidence in, then that does mean you can count on it, and you don't have to provision the more expensive and the later test. That's what the DFMEA tells you, right? But all of these things are, let's say, they're to be used intelligently. So if I've done that and I've gone for the lower detection, be really confident that that is a good detection. And also I will probably be less likely to do that on its own if I've got a higher current score. Do you see what I mean? Because if I'm more likely to make the mistake in the design, I absolutely need that robust detection. So some of that thinking will come into the way I plan the activity. But generally speaking, I think the advice mainly is to be really confident in the values or the detection controls that you're putting in there as being good ones, because there's no point in putting in a weak detection. Some of the scoring criteria, in fact, talk about how well validated particular analysis types or particular tests are to in-service environments. And I think that's a really important consideration when it comes to the scoring. Okay, another question in there is, how important is it to use a software for DFMEA? Different schools of thought on this. The software will enable you to find and store and recall information quickly, right? But I believe wholeheartedly that the majority of the value inside any DFMEA is in the team interaction and the discussion of the priorities on the design. So if you've got bad team behavior and poor preparation, no amount of software is going to cover that up. If you've got that necessary team engagement and emphasis on doing a good job in the DFMEA, for sure, a good FMEA package of software will help you maximize the benefit of the information you've got. And any other thoughts on that from anybody amongst the panel?
Yeah, I agree with you. So there are a lot of software on market, and all of them are quite good. So it's only how to manage data and how to go the method. So they are guiding you a little bit. But at the end, everything depends on how you and the team are working together and how you generate the information you want to bring in there.
A follow-on question on severity
Yes.
level. Would the severity level also temper that decision when relying on modeling against physical testing too, though? So I think that relates to the detections.
Yes, for certain it would. And it comes back to the consideration of alarm, and particularly for safety issues. If you can provision a test that would robustly detect, even late in the day, and therefore protect life, why wouldn't you? Yeah, so there could actually be a case, a case for that on the basis of a law, because we are talking about safety and we are talking about human life. There is another question coming, which I'm just reading now. How can we pursue to receive the effects and severity information from our customers without breaching disclosing intellectual property? Okay, so I don't think necessarily you breach intellectual property. There should be non-disclosure available between you and your customer. Okay, and if there's non-disclosure, you should be protected on both sides from that particular issue. So I think it comes back to the way you're contracted and the way your contract is protected with your customer. Any other comments on that from anybody in the panel? I agree, it can be a knotty issue.
Yeah.
Question on pre-work you would recommend to us. Yeah, so there is some guidance in this in the reference manual, and I think there's a slide, and if we actually chose to miss out, which was covered in section 1 with the to the DFMEA. So we would ask to, first of all, of course, you have to have a good concept. You have to have a design on which to have a evaluation. You have to understand something about the system it sits in from the severity's point of view to understand propagation. Other inputs you consider will be service experience. Make sure you have the right team. So all of these aspects are actually covered. These aspects are within the reference manual, but I'd recommend a good read of the reference manual. Question in there, did you have chance to score of severity? If yes, in which situation? Don't come across this very often, and I think the reason we don't come across this very often, I think, as engine manufacturers, particularly, and I speak as one, okay, is that our house styles and our design styles for our products tend to be evolutionary rather than revolutionary. Okay, so the systems and the architecture that we build from tends not to change too much from product to product, and most of the OEs are like that. So in that situation, there is an established architecture, and that architecture is pretty much a given. There have been instances, though, where I've seen failure modes identified and effects propagated and discussed further up the system that have led to the consideration of a design change in the system architecture. And it's a design change in the system architecture that will lead to a change in the severity score. So I hope that helps.
You could also consider the complexity of your component. If you have a very complex component, there might be some ability to address some safety issues within the design of the component. So the component itself could be thought of as a system.
Yes. There was a question about whether or not we could share some system level DFMEA examples. We can't do that just now, but I think there's for certain a chance to at least show something. But we do need to be careful that we don't give away anything to competitors as well. So anything that we can share in terms of system DFMEA, I think will have to be mutually agreed between us and will to be suitably redacted. if you see what I mean, so that we can demonstrate to you what we do without necessarily showing you the data. Is that fair, Steve, do you think?
I think so, yes.
Some questions, further questions in there, all coming in now. This is good. This is good. I like this. I'm going to allow another 10 minutes of questions if people are okay with that, because I think we only have 10 minutes more of material after that. Okay. There was a question on mistake proofing which caught my eye. Right. So, would you link potential misassembly, for example, to a failure mode in this, or conduct DFMEA session, DFM or DFA sessions separately? And the same for a repair and overhaul, etc. I think misassembly is potentially something that will come up in a DFMEA session. My personal belief that it's not best dealt with during DFMEA. Okay. I think it's more of a DFM, DFA type question. So if you're going to error-proof a component or put some controls into the assembly process to prevent a misassembly, that's a good conversation for DFM, DFA, DFM or O, okay, in that environment. But remember, the predominant concern of DFMEA is to produce a good design that gives you the functionality, okay? And in the constraints inside of DFMEA, most of the standards will state that you can assume that it's manufactured and assembled correctly, okay? For sure, this kind of issue will come up in DFMEA sessions. Don't treat it through DFMEA. Make sure you identify the issue and treat it effectively through a good conversation with or the overhaul organisation. Is that fair, Steve, Stefan?
Yeah, I think the key there is that the DFMEA being done early and with the cross-functional teams, it allows you to identify those issues that can then go be addressed with a design for manufacture assembly or design for maintenance activity.
That's fine.
And Stephanie, I would add that manufacturing and assembly life cycle phases of the product can bring function into the analysis scope. And this is a way to capture them and to make sure that the design is taking into account some requirement of the subsequent life cycle of the product. So my answer would be slightly different than yours. Could be captured in the FMEAs by having a full scope of the life cycle of the product. Especially if you want to automatize the manufacturing.
I wouldn't discourage, I don't turn my nose up or anything like that at people who talk about mistake proofing in a DFMEA, because at the end of the day, all you're after is a good design that will always meet the customer expectation. So it's a benefit to raise it in the DFMEA and treat it even through a DFMEA, I don't mind. I just through experience have found that the most effective way is actually DFX conversations, and design for assembly conversations and design for manufacture ones.
There's a question here about asking if we can follow up on the bespoke component requiring testing verification opposed to simply being validated as part of the system. For example, a valve in a piston engine. I think this question is getting to the detection method.
Yes.
If you're detecting that as part of the larger system versus the component testing itself.
So I think rig testing often comes up in this sort of consideration, as long as we're not talking about, let's say, final product testing, validation testing of the product, okay? If we're talking about something that informs the design or potentially detects failures inside the product development process, that certainly deserves a place in the detection or even in the occurrence scoring, okay? Because if they're early enough, these can be prevention. They can inform you not just of the validity of a solution concept. They could inform you about the requirements that you need to address. They could even tell you which failure modes might occur. So absolutely, they're vital. I think actually the earlier they come, the more they're likely to be scored as occurrence, the more they're likely to inform the design choice. Okay.
There's a question about reference PFMEAs. Are there reference DFMEAs?
Okay. You might be able to comment as well as Andrea and Stefan, but we haven't got any in Rolls-Royce. I believe we could have. We have a good library of past examples on certain component types and certain system types. We haven't got to the point, as we have with PFMEA work, of separating out failure modes and potential causes and making a library out of them that we can reuse. Personally, I believe you can do exactly the same with DFMEA as you do with PFMEA. We just haven't pressed the buttons yet.
Yeah, we have some catalogs for the several parts to go through, but there's not like the reference PFMEA or something you can just take and approach on your part.
So the only example. Sorry, Steve. Go on.
I was going to say, philosophically, as the industry matures and as we develop DFMEAs, you know, the next iteration of your design could be, you know, 60% of reuse, you know, 40% new, and definitely that 60% could be considered almost as a reference DFMEA. You could take that as a standalone input, you know, to evaluate within your new design.
I could point at one or two small examples of reference type work in DFMEAs inside Rolls-Royce, but it has more to do with the reuse of standard parts, for example. You don't always get the same failure mode propagation from the failure of a particular standard part, but for certain you always get the same kind of causes present. Yeah, so you can reuse part of the information. So I've certainly seen and been involved with some work of that kind, but it's in no way forming a kind of library in the same way that we are pushing with PFMEAs. There's no reason why we can't go there, I don't think. Okay, any other questions in the chat that we ought to address?
So there's a question on when you move to a new lower score to the original scoring side of the DFMEA after control detection improvement actions are completed or after the improvements are actually validated on a product. So I think this is getting at when do you actually implement the updated RPN severity occurrence detection?
Well, the reference manual method that we're advocating suggests you don't change the initial scoring, so the left-hand side scoring, but you do change based upon the recommended actions on the right-hand side. And by that means you keep the reference score of the original score and you can track the improvement perceived through the use of the DFMEA. Now, most areas operate the scoring in that sort of way. But it's not, I don't think it's actually universal that DFMEAs are always scored in that same fashion that we're advocating in the reference manual.
I think in general, you can estimate the reduction in RPN on the right side of your DFMEA, based on what your intended actions are, but it's not finalized until you complete those actions. So until you have that action results field filled in, you can't consider that improvement as official.
You can't cash it in. Yeah, but for certain, when you have completed the action, then that's valuable. You complete the action, it's actually valuable information to the next time you do a similar DFMEA, and is one of the big advantages of the recommended action section. A recommended action this time can become standard work next time and go into the prevention and detection columns of the original score. Okay, I was going
to say we have 10 minutes left if you want to move on.
We have 10 minutes left. I was going to suggest we just move on. Is it your turn, Andrea? I think it is.
Yeah, I think so. So then we go to the last slide now. So please, yeah. So we just make a short summary, and then I give further information where you just can find maybe some answers of your questions. So please click next. What we here provided is, let's say, a guideline or help when you just finished your Design FMEA. There are typical questions you can answer to think if you really have a comprehensive Design FMEA, or if you just forgot something maybe. Yeah, so I think we go through all the steps, and it's quite clear that at the beginning you just have to think about what items do you want to define, and then also what are the functions, primary and secondary, and what are all the requirements, and did you provide them in a precise language that everyone could work with this document afterwards. So yeah, I just do not want to go in detail in this slide, so we will provide afterwards you these slides, and you can also download them on our site. So just take it with you when you're doing the DFMEA and the document, and just go through and think if you can just answer all the questions with yes. So if it is so, you will have a quite good documentation and also a good Design FMEA. So next slide. So everything what we just said until now is also in the reference manual 13004, and it's you can find it on the AESQ website. Also, there are some trainings available for FMEAs, and which will support this approach. And we also provide some information, and also all these slides will be uploaded on the AESQ site on the subject matter interest group. So on the next slide, you can just see where you can find us. I think all of you just found how to register for these events. So I think you just already know the AESQ site, and there you will just find also the interest group, and there the defect prevention where the reference manuals are also part of. And when we click next, I think, yeah, as I said, all of this will be on the AESQ website in the next days, the video as well as these slides. And there you will also get a link to find all the informations. And then I think the next slide would be the end. Yeah, so I see. Thank you for attending. And Rob, maybe you want to say something?
I'll say thank you for attending as well. Thanks for the participation on the chat as well. I would say that in wrap up, of course, yes, the material will be provided from today and the video recording of today. We've recorded, of course, lots of questions in the chat. I realise that we've gone through the chat. We've not answered every question. And I believe I was potentially at odds when I answered an earlier question on severities and different lines in the DFMEA. So I'll relish the opportunity to put that right inside the question and answer And apologies to the person whose question that was, because I'm afraid I got myself slightly knocked up thinking ahead. Okay, so we will hopefully wrap up the questions and provide some stock answers to them, as well as the ones that have been recorded and captured in the chat. And really, we just invite your ongoing participation, really. You can find us, as we've stated, inside the website, on the SCE website and the subject matter interest group pages. Please do use those to raise questions, to ask for help if you should need to. Looking for people to help us to improve this type of communication. So we'd love your feedback from today. So yes, from me, and I guess from everybody who's taken part in delivering today, thank you very much for coming along. Thank you.